Welcome. In this video, we are going to see about the previous year question in NEET in the year of 1999 in physical chemistry under the topic of some basic concepts in chemistry. Let's see the questions. In this year, 5 questions are asked. So let's discuss the number of atoms in 4.25 gram of ammonia approximately. We have already seen this type of problem in many times, okay, in my previous videos. If you didn't watch that, you can watch, okay. Let's discuss how a number of atoms. There is a one formula which means to find the number of atoms, it is equal to number of moles multiplied by Avogadro number multiplied by atomicity. What is called atomicity? Atomicity is nothing but atoms per molecule. In this ammonia, there is a 4 atoms, 1 nitrogen plus 3 hydrogen. So there is a 4 atoms. That is atomicity. Atoms per molecule is nothing but atomicity. So atomicity is 4. Avogadro's number is nothing but 6.023 into 10 to the power 23. Okay. Then multiplied by number of moles. What is number of moles? Number of moles is very simple. Number of moles is nothing but given weight divided by molecular weight. Given weight is what? Given weight is given 4.25 gram, it is given. Then what is molecular weight? Molecular weight of ammonia, it is very simple. For nitrogen, atomic mass is 14. For hydrogen, atomic mass is 1. There is a 3 hydrogen. So we need to add 3. So it is nothing but a 17. So 4.25 divided by 17. This is a molecular weight of ammonia. Let's solve 4.25 divided by 17. You will get around 0.25. 0.25. This is a number of moles. So if you multiply 0.25 multiply with this 4, 0.25 multiply with this 4, you will get basically 1, right? 0.25 multiplied by 4, you will get 1. So 1 into 6.023 into 10 to the power 23 is also 6.023 into 10 to the power 23, because anything multiplied by 1, it will give the same thing. Okay, so the answer is 6.023 into 10 to the power 23. So this is an answer. Okay. Okay, we see the next question. Yeah, this is one of the fundamental question, and this is very basic. Okay, you can solve it mentally. Which one of the following statements is wrong for gases? Gases do not have definite shape and volume. This is right or wrong? They are asking the wrong statement. This is a right statement. Okay, because gases do not have definite shape and volume. If I burge a gas in a water bottle or else any cubical box or cylindrical shape, it will adopt the shape. Okay, gases must have what is called a weight or mass, but do not have shape and volume. It will occupy or else it will adopt a shape, it will adopt a volume to the container from we what is called we budget the gas or else we store the gas. Okay, so this option is right. So this is not an answer. Volume of the gas is equal to the volume of the container filling the gas. Okay, this is true. Okay, this is true. Volume means what? Volume is nothing but a three-dimensional space a object is occupying, which means if I'm sitting in a chair, how much space I occupied in that chair is my volume. Okay, there is a difference between volume and mass. Volume is nothing but, take an example. If I am sitting in a chair, okay, how much space I occupied in the three-dimensional. That is called volume. Okay, if a gas occupied, or else if a gas is I store a gas in the container, the volume of the container is nothing but a volume of the gas. Okay, this option is true, but is not in the answer because they are asking the wrong answer. Okay, then the option C, confined gas exerts a uniform pressure on the walls of its container in all directions. This is also true statement because gases always exerts a uniform pressure on the walls of the container. Okay, then this is also true statement. This is not our answer. Okay, then option D, mass of the gas cannot be determined by weighing the container in which it is enclosed. This is a wrong statement. How it is wrong statement? It is look like a true, but there is a one word. It is enclosed. If you have a container with the gaseous molecules, you can measure. It will give 5 grams. After without gas, okay, without gas, you should measure the container. It is a 3 grams. So the mass of the gas is 2 grams because 2 gram is nothing but 2 gram is added by the mass of the gas. Okay, you should measure container empty, then you should measure container with the gas. Minus these two, you will get the mass of the gas. Okay, with the enclosed, you cannot determine the mass of the gas. There should be in the enclosed term should not be included. The container should be empty and the container should be filled with the gas. These two terms are included to find the mass of the gas. So the D option is wrong. This is our answer. Okay, it needs a simple mental calculation to find simple mental ability or else mental thinking to solve these type of questions. Okay, then this is a third question. This is very simple. Okay, percentage of lead in lead pencils. Percentage of lead in lead pencil. This is very simple. No pencil in the world is made up of lead. Okay, pencil is always made up of graphite only. So there is a no lead pencil. So there is a no lead percentage. So the option is answer A is 0. Okay, this is a very fundamental one. There is a no lead pencil in the world. Okay. Then this is a fourth question. An organic compound containing carbon, hydrogen, nitrogen gave the following analysis. Carbon is present as a 40 percentage, hydrogen is present as a 13.33 percentage, nitrogen is present as a 46.67 percentage. Its empirical formula would be. What is the empirical formula? Empirical formula is given in the four options. We need to pick the right one. That is our task. How to solve this? I'm always give one trick. If you see the question contain the percentage, which means mass percentage, we need to divide this mass percentage by the atomic weight. So, for example, carbon is 40, hydrogen is 30, nitrogen is 46. If I am considering 40 and 46 is same, approximately equal, then carbon is one time, nitrogen is one time, hydrogen is should be less than one time, right? If you consider only this percentage, carbon is one time, hydrogen is one time, hydrogen should be less than one time. But you see the four options, hydrogen is always higher in amount than the carbon and nitrogen, higher in amount than carbon and nitrogen both. So how to solve this? Okay, there is a one problem. The problem can be solved by the atomic mass of individual atoms. What is the solution? There is a one solution. If you divide the percentage, what is called this percentage, carbon has a mass of 12 gram. If you divide 40 percentage divided by 12, because 1 mole of carbon atom is 12 percentage, sorry, 1 mole of carbon atom is 12 gram. Okay, 1 mole of carbon atom is 12 gram. They gave 40 percentage. They didn't give any mole fraction or else any gram fraction or else any weight fraction. They just gave percentage. So we need to convert those percentage into mole so that we can find the empirical formula. Because in option A there is a 2 mole of carbon, option B there is a 1 mole of carbon, option C there is a 1 mole of carbon, option D there is a 2 mole of carbon. Okay, because C1 means 1 mole carbon, C2 means 2 mole carbon, so that we can find the number of moles. Okay, so to find the number of moles, 40 percentage divided by 12, which means 40 percentage divided by 12, which means 1 mole. For per mole, everything anything in the denominator it comes with the word per. Okay, 40 percentage per mole of carbon, per 1 mole of carbon, it will give 3.33 percentage. In the same way I am solving for hydrogen. Hydrogen have always 1 gram. So if we divide 13.33 divided by 1, it is nothing but 13.33 percentage. Okay, nitrogen weight is 14 gram. Okay, if I divide 46.67 per 1 mole of nitrogen, that word is main, per 1 mole of nitrogen, so I am dividing it with the 14, it will also give 3.3 percentage. Okay, 3.3 percentage. So carbon and nitrogen are having the same percentage. Carbon and nitrogen have same molar ratio because it is nothing but a per mole. Okay, which means per mole I am calculating, so it will give the mole. Carbon and nitrogen should present in the same mole fraction. Okay, in option A there is a C2N2, it can be an answer. Option B there is a C and N, it can be option. Option C there is a Cn, it can be option. But option D it is C2N, this is not an answer. This is not an answer. So in among the three options, which is correct, we can determine by the hydrogen. Okay, hydrogen is nothing but a 13.3 percentage. So what is the ratio between carbon, nitrogen, and hydrogen? If you multiply 3.3 with 4, you will get 13.33. Acceptable. You will if you multiply 3.3 with 4, you will get 13.33, which means hydrogen present 4 times higher than carbon and nitrogen. Okay, hydrogen present more than 4 times carbon and nitrogen. So C present 1 time, nitrogen present 1 time, hydrogen present 4 times. This is answer. Or else C present 2 times, nitrogen present 2 times, hydrogen should present 8 times. There is a option containing this, not this. So option C is answer. Option C is a answer. This is a way of solving these type of questions. Initially, you need to divide the weight percentage. What else? The percentage divided by the atomic weight of 1 mole of each element, so that you will get the weight per mole of each element. Okay. This is a final and interesting one question in this year. How many grams of dibasic acid should be present in 100 ml of its aqueous solution to give decinormal strength? They won't give any numbers in here, just decinormal. What is meant by decinormal and normal? Okay, normal, it is very simple. Normal means it is a one normal. Okay, decinormal means it is 0.1 normal. This is standard. You can come across in many places. Normal solution means it is always one normal, not a two normal, not a three normal. Normal solution means it is one normal. Decinormal means it is a 0.1 normal. So you need to find, to prepare 0.1 normal of a dibasic acid solution, how many grams of dibasic acid is required. Okay, I repeat, to make 0.1 normal dibasic acid solution to 100 ml SMF, how many grams of dibasic acid is required? Okay, it is very simple one. For preparing the 0.2 normal dibasic acid solution, weight divided by equivalent weight, right? Weight divided by equivalent weight multiplied by 1000 divided by SMF. SMF in this case is 100 ml, because I need to prepare the 100 ml solution. So I take the 100, I took the 100 ml SMF. So it is 100. Okay. We need to find this X. Then what about the equivalent weight? Equivalent weight we can find. There is a molecular weight. Okay. There is any hydrogen, which means ionizable hydrogen. Yeah, there is a ionizable hydrogen, because they give the dibasic acid. What does mean by dibasic acid? Monobasic acid, tribasic acid. Monobasic acid, it contains one ionizable hydrogen, because hydrogen can present as a H plus. So the valence is +1. Dibasic acid means it will provide 2H plus. Tribasic acid means it will provide 3H plus, which means the valence is increases. So molecular weight divided by valency, it will give equivalent weight. That is a way to find our equivalent weight. Okay, that is the relationship between equivalent weight and molecular weight. Okay, so if you have a dibasic acid, so the valence is 2. If you divide it by 2, it will give an equivalent weight. So the equivalent weight is 100. Okay, so X divided by 100 multiplied by 1000 divided by 100. Here it is 0.1 normal. Okay, you can divide. Okay, there is 1 divided by 10. This 10 goes here, right? This 10 goes here. 10 into 0.1, it will give 1. So you should take 1 gram. You should take 1 gram of dibasic acid and dissolve the 1 gram in 100 ml solution. You will get the 0.2 normal of the dibasic acid solution. Okay, this is very interesting in the titration analysis. Okay, decinormal means 0.2 normal. So equivalent weight, to find equivalent weight, it is nothing but molecular weight divided by the valency. What is valency here? It is a dibasic acid, so the valency is 2. Okay, simple one.